On these next two questions, you're looking for parallel and perpendicular. So we're going to examine parallel and perpendicular. So this is going to look at the graph of the line is shown below. Write the equation that best describes a line parallel. Okay, key words here, guys. Parallel. Automatically, we're looking for something with the same slope. Okay, and I'm kind of writing off the grid here. Same slope. Parallel lines have the exact same slope. So let's go back to the y equals mx plus b thing. That means you're going to have two lines that both have the same m. That's what parallel means. So let's look at the line that we have. So the graph of the line is shown below. We want to find a line that's parallel to this one. So the first thing we want to do is, what is the slope of this line? Okay. Now there's a little hint box here, and I already filled this in. Parallel lines have the same slope, and perpendicular lines have a slope that has the opposite sign and is reciprocal. You really don't need to fill that in. They're opposite reciprocals. So if one is positive, one is negative. If one is 2 over 3, one is 3 over 2. Find the y-intercept of your new line and then count the slope. Okay. Well, first of all, let's look at the slope here. Let's pick 2 points on this line that we can see. They give us 2 right here, right? Now, remember, what is slope? And I'm going to come back and use the same color. All right? Slope is the change in y over the change in x, which is your vertical change, your up and down, over your horizontal change. So I'm going to count. Let's go vertical first, okay? So I'm going to go vertical. We're going to go vertical first. So to get from here to here, I'm going up. 1, 2, 3, 4, 5, 6, 7. So that's a positive 7 vertical climb. So my slope has a positive 7 on the top of it, okay? So now let's look at my horizontal slide. So I'm going to get from here to here. I go 1, 2, 3, 4, 5. I'm going to the right 5. That is a move of positive 5. So my slope is actually going to be positive 7 over positive 5. That means I'm looking for one of these equations down here that has that same slope, so I can start throwing stuff out. First off, if my slope has to be 7 over 5, I can throw this guy out because this slope is 5 over 7. That's wrong. This slope right here is negative 5 over 7. That's wrong too. This slope is negative 7 over 5. Once again, my slope is not negative. So that's wrong. So my only option is D, which in fact has the same slope, 7 over 5. Now let's say not all the answer choices were easily thrown out like that. The next step would be, let's say I had 2 answer choices that had 7 over 5 as a slope. What I would do next is I would look at the y-intercept. This new line I'm looking for passes through 0, negative 5. Now if you put 0, negative 5 on the graph, that is actually the y-intercept, which is your what? Your b, right? Do you notice how this says plus negative 5? Because negative 5 is your b. You would look at the equation that had the same b, okay? So that's how you do 4a. So let's look at 4b. So if I come down here and I'll look at 4b, okay, we're going to do the same thing, and we're going to be looking at parallel. Let me keep my colors consistent here. Which equation describes a line parallel? Okay, so once again, I'm a little off the grid here. That means the same slope, okay? So we're going to look at that slope piece first and start eliminating answers, then come back to what we need. So once again, let's play the slope game. The slope is equal to the change in y over the change in x, which is your vertical up and down change over your horizontal left and right change. So if I look on my graph, let's do my vertical change. I'm going from this point to this point, okay? Now, in this one, I have to actually go down 2. So my vertical change is -2. I went downward. I went down 2. So that's a -2 change. So now let's look at the x portion, the horizontal change. And that's 1, 2, 3, 4, 5, 6, 7, 8. Now that is still a +8 because I'm getting bigger. I went to the right. So that's a +8. So that is my slope. Now, you have to reduce your slope. This is reducing your fractions. Again, the calculator will do this for you. But again, being a good math teacher, I have to show you how to do it. The lowest, the lowest common denominator between 8 and 2, not denominator, but the greatest common factor actually is 2, the GCF. So I'm going to reduce this, and since it's a negative over a positive, that's going to stay negative. This will reduce to -1 over +4. So that is your slope. So I'm looking for a line that has that same slope of -1 over 4. So let's look at our answer choices. +4. Nope. -4. Nope. +1/4. Nope. -1/4. Yes. And again, let's say you had 2 answer choices that had -1/4. Well, this here, 0, -3, the point that it gives you that's on our new line is at 0, 1, 2, 3, -3. That is our B. That actually happens to be our y-intercept. And if you look here, you have plus -3. So that's how you do the parallel equations. Now, if we want to look at the perpendicular ones, I'm going to give you 4C here. We're going to look at 4C. Look at the graph of line K and the graph above. So we're going to actually look back at the graph we have above. And what is the slope of a line that would be perpendicular to K? So on the test you might see something like this, and it'll give you a line, it'll ask you what's the slope of a line that is perpendicular. Well, we've already figured out our slope, okay? So you're already ahead of the game here. But on the test, you'll have a new line, you'll have to figure out the slope, okay? We got -2 over 8 using the stairs. So this is our slope, is -1 over 4. Now, perpendicular lines have opposite reciprocal slopes. Now, what does that mean? For example, if one line has a slope of +2 over 7, its perpendicular is going to be -7 over 2. I'll give you another example. If the perpendicular line is -5 over 6, or the original line, the perpendicular line would be +6 over 5. So they're opposite flips, they're opposite reciprocals. So since our original line up here, since our original line is -1 over 4, what would our new line be? +4 over 1, which is just the same thing as +4, so your answer is going to be C. So you'll get the graph, you'll find the slope like you do on the graph, and then you'll just do the perpendicular part of it. And to kind of finish off this section here, we did a couple of examples here on 4C. The slope of lines that are parallel, let's review, always will be the same, okay? So these guys are going to be actually the same. All right? The slope of lines that are perpendicular will always be opposite reciprocals. Okay? They'll be opposite reciprocals. Now don't worry about this in here. Now perpendicular, if you guys don't remember, also means that they intersect at a 90-degree angle. Okay? When we look at perpendicular lines, they look like this. They make a right angle. Okay? Remember when we talk about right triangles have a right angle in them because the legs are perpendicular. So that's that big word there. It says here, draw 2 parallel lines. Well, all you have to do is just draw 2 lines that are parallel. And if you remember from when we did the special angle pairs, when we do the special angle pairs, we actually have little parallel markers. We use little arrows to indicate the lines are parallel. When we do perpendicular lines, all you have to do is draw two lines and make sure that they intersect at a right angle and that you have that little box to indicate that they're perpendicular. So that's just kind of a refresher on perpendicular. Okay, so let's look at 5A. I'm going to do 5A and 5B on this video, and then I'm going to patch to another one. So 5A says line LM passes through points L negative 2, 2, and M negative 2, 3. Okay, so that's our line here. Draw the line that is perpendicular. Okay, that perpendicular, what does that mean again? That means I need a 90-degree angle to LM and passes through 4, 2. Now, let's go over 4. Let's plot this point. This is our new line. We'll do perpendicular with red. So I'm going to go over 4, 1, 2, 3, 4, up 2, because remember this is an XY coordinate. We go right and left, up and down. And I need to draw a line that's perpendicular to this one. Well, you see this one's completely vertical, right? It's completely vertical. So when I draw the perpendicular line, for it to be perfectly horizontal, it's got to be perfectly horizontal. That's how I make a right angle, right? You know, not that tough. Well, the question is, what is the equation of a line like that? Well, when you have vertical lines, so let's talk about this briefly. Whenever you have a vertical line, you have all points on this line have the same x coordinate. For example, M is at negative 2, negative 3, right? This one is at negative 2, negative 1. This one is at negative 2, positive 1. You can see they're all negative 2, so no matter what I do with y, x is always the same. So when you have vertical lines, they are always x equals, and then whatever the x coordinate is. So this line is x equals negative 2. Anytime you have a vertical line, that's how you write an equation. It looks odd because we're used to y equals mx plus b, but a vertical line has a slope that we cannot define. And that's something for a different lesson, but we cannot define it. The horizontal line, if you look at the horizontal line, no matter what my x value is, my y value is always the same. So this is at 4, 2. This is at 2, 2. This is at 0, 2. No matter what my x value is, my y value is always the same. So horizontal lines are y equals whatever the y coordinate is for all your points. So we're looking for the red line. That's a horizontal one. So we're looking for something that says y equals. And on this line, all y coordinates are 2. So that is our answer. Y equals 2. Another reason horizontal lines have that equation is because you know how we have y equals mx plus b? And b is the y-intercept? In this situation here, the slope is actually 0 because there's no rise, right? If it's flat, there's no rise. So you have y is literally equal to the y-intercept, which is b, which is why you have the equation that way. All right, let's do 5b, and then we'll flip over to the next video. Okay, and again, this is all review of stuff that we did a while back, so hopefully it's kind of jogging your memory a little bit. All right, so line AB passes through negative 3, negative 2, and that should say 1, negative 2, by the way. So we're presented now with a horizontal line, and we're being asked to find the perpendicular to that, which means we need a vertical one, okay? So remember what I told you on the previous page, okay? Let's review. Vertical lines all have the same x coordinates, so they're going to be written x equals. Horizontal lines all have the same y coordinate because the slope is 0, so they're going to be y equals whatever all the y coordinates are. So let's look at this. This is a horizontal line here. So what are all of my y coordinates on this horizontal line? They're all at -2. So this line is y equals -2 because no matter what my x coordinates are, y is always -2, okay? So I'm looking for a vertical line, so I don't want anything that says y equals, so I can automatically toss those guys out. So now I'm looking for, okay, 3, -4, a line that passes through 3, -4. So I'm going to go over 3, 1, 2, 3, down -4, and I want a perpendicular, meaning 90-degree angle line. So that's going to be a perfectly vertical line running up and down here. Now, vertical lines all have the same x value. Well, what's the x coordinate of every point on this line? 3. So there's your answer. And there are, like I said, knowing your vertical and horizontal lines, oh, sorry about that, so that would be circle this. Knowing your horizontal and vertical lines really help. And I'm going to show you a couple more examples here in 6A and 6B on the next video.